All right, welcome everybody. Very excited for today's discussion that we're going to have. Today's Fireside chat is going to be about combining programming with math instruction to kind of enhance it in a way. So we have some really great guests here to kind of spark this conversation. Each of them have CS and math backgrounds, which is really cool. I think they're going to have a lot of great things to say. So I'm going to have each of you introduce yourselves in just a minute. But for anyone that doesn't know, I'm Joe Mazzone. I am a computer science teacher at Davies Career and Technical High School in Lincoln, Rhode Island. And I have the pleasure of having a conversation with these people today. So Jeramie, if you want to go first and just introduce yourself.
I'm Jeramie Oliveira. I teach high school math and with code in Simi Valley. That started a few years ago, and we'll get into that in a little bit.
Excellent. And Lisa?
I'm Lisa Ryder. I teach high school math and computer science at Westlake High School in the Caneo Valley Unified School District, very close to where Jeramie teaches in Simi Valley.
Excellent.
Neighboring districts.
Dr. Mitchell?
Yes. Well, I'm so excited about this topic tonight. I'm Dr. Mitchell, and I actually teach at an early college/college freshman teaching Python programming.
Oh, I love hearing that because if people don't know, Python is my favorite language, so I talk about that often. So that's great. And then where is that? I'm sorry if I didn't hear it. Where in the country? What state? Dr. Mitchell, I'm sorry. What state do you teach? Maybe you can't. Can you hear us still, Dr. Mitchell?
Yeah, I had to change. That is part of the techie world. It just went out. You know, I've been working all day teaching, so it's like It's tired now. So I had to switch over.
I understand completely. I had to follow up. I said, what state did you teach in? Do you teach in?
Oh, I teach in North Carolina, but the schools are in North Carolina, but I'm remotely.
Okay, excellent. Very good.
Yeah.
All right, so where we're going to kick this conversation off with is what inspired this Fireside chat was really Jeramie and some work he's doing with math with code. Jeramie, could you explain more maybe about your brainchild here?
So a few years ago, about 5 years ago, actually I started teaching it 5 years ago. So in May of 2015, I was approached by one of my admin, and I was literally given only, I'm going to go ahead and share my screen here so you can see it. I was given just this outline. And so the class itself was created by the University of California. They have had a curriculum integration program, all the CTE stuff they were creating. And so this was for the software systems development pathway. And it was just an overview of how we could bring computer programming and geometry together. And I was asked if I could, as one of our tech leads on campus, be someone that could try to teach this. And so, you know, you're looking at this course content, and it's just an outline. There wasn't really much more to it than that. Mm-hmm. And so from that, I had the opportunity to work with one of my colleagues over at our other high school in Simi Valley at Royal High School by the name of Dan Schuster. And he had been doing a lot of work trying to get students more opportunity to do computer programming when they're in high school, because we have so much of it's hard to get students to even opt to take computer programming because it's an elective class. Yeah. So how can we encourage more students to do this? And when we saw these classes that were already created and already college approved for UC and CSU, and they replace the math class. So the students actually get geometry credit for the class, and we can bring that computer science component into it. And that's when we started looking at these programs more in depth, and Dan and I sat down and we started talking about it, and he was one that introduced me to Pencilcode.net, which is what I use and have been using. Wonderful program.
Yes.
And it gave me a chance to go and start exploring this. The difficult part for me is I'm not a computer programmer. I'm a math teacher, but I happen to be very tech savvy. So I just sat down and I started to play. And the first year of class, I only taught the geometry class the first year. I told the students, this is new, this is exciting, and we're going to figure this out together. And that first year, I learned so much from my students. I would not be successful today if it wasn't for the kids that were in that class. Because when I was trying to figure out how to do something and trying to get a program out in front of them, I'd just be stuck and I'd put it up to the kids. And I would say, here's where I'm at. I'm stuck. This is what I want to do. How do I get there? And some of my students that had some programming background already would start talking to me about it. They would send me little information here, try this, or I try that. And we learned so much together. And a lot of those things I learned, I still have to use with my students today. Mm-hmm. And then a couple years ago, actually when Lisa, you were there for my training, that group of kids that came and talked at that training, they were some of the ones that said, hey, I love what you're doing, but let's see if we could do this a little bit better. And they taught me and reminded me about breaking this down into smaller, independently testable pieces of code, so that they could build these big programs I'm having them do. And that just changed everything. So everything I've been doing for the last 5 years has been learning about it, creating it, going forward with it. And then the kids in the geometry class had so much fun. And I've been an intervention teacher for so long. I went and looked and said, I went to the UC people and I said, where's the Algebra 1 class? They had geometry, they had Algebra 2, but there was no Algebra 1 class. And the email I got back from them was, we don't have it yet. Do you want to write it? And so I sat down. Yes, I sat down. I started putting it together. And I sent them the first draft, and they said, this is almost CTE. What I had was perfect for a class, but it wasn't quite the CTE they wanted. So they got together with a group of teachers in Manhattan Beach for a couple of days. We went through the draft, we edited it, we changed it, and we created the Algebra 1 that's now called Algebra 1 Abstract to Visual on the UC system. And now there's 3 levels: Algebra 1, Geometry, Algebra 2, which meets all the requirements for high school. And the kids can actually do all 3 levels and get a little bit of code in Algebra 1, do a little bit more difficult code in Geometry. And then we get to Algebra 2, where I'm doing, I have them solve a system of equations. We do an n-by-n system of equations using matrices. And so we code the matrices and have them do that. And it's so cool because they get a chance to see little things and then bigger things. And, starting with just input, output, small stuff, strings and stuff, to we also code in Algebra 2, we code synthetic division, and that uses a recursive algorithm and break statements. And the kids that do my class have gone on to they've done the elective classes, they've done the AP Computer Science, and they came back to me and said, you know what? I thought AP Computer Science was easy, and I thought it was supposed to be hard because I knew the logic that you did in the math classes.
Mm. That's fantastic.
That's great. And so, Jeramie, and you're creating some resources around this that you're going to be sharing with the community?
Mm-hmm. So all of the stuff that we have created, Dan has been amazing, and he has our website that we created. He's the webmaster for that, so I'll go ahead and share that right now so we can see that too. Let's see here. So we do have a website, and what we have been doing is, for the three of us that are working on this in Simi Valley now, Dan has moved on. He is a ed tech TOSA for our district now. And so my counterpart now over at Royal is George, man, he's going to nail me for mispronouncing his last name, Karangia. Sorry, George. I'm sorry I mispronounced your name. But as we get stuff, we share it all here. And so there is a little bit of some stuff here in the lesson archive that right now it's just Algebra 1. But if anybody wants to know more about what I have total, what I've done for Algebra 1, Geometry, or Algebra 2, they are welcome to reach out to me. My Twitter handle is Mr. O SVHS. So you can reach out to me through Twitter and send me a direct message with your email address, and I'll be happy to share my resources with you that go over and above what Dan has posted so far in that Math with Code website.
So I've shared that over in the chat too for people to be able to see on this. So you can access that website. So that was really what's ended up sparking this conversation. As we can see over here, Christopher commented also and just said it is brilliant to have to have programming in math courses. And I think all of us here believe that it can create more interest in math and in engagement. And that's the kind of the conversation we're going to have. So first, Jeramie, you started to talk about it, but I'd like to hear from Dr. Mitchell and Lisa about how should programming really be incorporated into math? What are some examples of activities or things that make really good connections that need to be taught in certain math courses and just work so well to do things in programming?
Well, I think what sticks out, what you had mentioned, was system of equations. That is my favorite. And I have taught it, when I first started teaching, I started teaching mathematics, and, coming from a business career background and having to use my math mind, that I've always loved math, but I really wanted to do technology and programming because I was a web developer. But in infusing with students is, I would always say, correlate. I love project-based learning. And so I usually work collaboratively with other math teachers, being that I, currently just teach computer program all day long, but I still stop those moments with math. Like right now, my students are doing drawing. They're doing different pictures, using the draw line, draw circles, and that coordinate plane, I was able to bring it out. I love geometry. So they were able to see the X and Y coordinates. So it gave them a new visual, like, wow, I didn't really think I would ever use this geometry in Python, right? But they were able to, and I make them get that good old graph paper out. I love it. It's fresh, it's good. Plot it all day long with all the quadrants. But I think that's what I have done is really just had the opportunity to do the project-based learning so that they can actually see everything, the correlation, the similarities of like, wow, this is infused into this programming as well.
Yeah, I think for sure how you do this. This is the strongest way you can do project-based learning with math, right? I think if someone's really looking to make a really strong project-based learning math course, there's going to be some programming in it for sure. Lisa, what are some of your thoughts on this with how we incorporate this?
Well, I have a couple things. One is after I attended Jeramie's training, the UCCI training, we did bring in an Algebra 2 for the 21st century class last year, 2019-2020. And our goal was to focus that on kids who struggle in math and see if this could spark an interest. But I think about my normal classes, I do think that geometry, especially for me, geometry has so many opportunities because of the graphics. Any graphics program you're using is using a coordinate plane, and there's so much going on there. There's so much that you could bring in and use, with turtle graphics and things like that. Pencilcode especially, just thinking about sizes of things and similarity, using all that stuff in geometry, I think just brings it home to the kids. Here's something you can do with your geometry knowledge, and I think it's so fun to watch kids when they can do something, type something, and make something happen. It's so exciting for them. It's just sort of is inspiring. But anything that's algorithmic, obviously, is going to lend itself to make a program. So anything that you do in algebra, even just finding slope, that's a really basic algorithm, and having the kids write a program that they could use on their calculators to calculate slope is very exciting to them. Even though those programs exist and you could just download them, I think it's exciting to have them do those. And one of the things that I got really excited about recently, one of my colleagues at Newbury Park High School introduced me to this calculator. I don't know if you guys have heard of this NumWorks calculator. It's a new graphing calculator, and you can program it in Python. So it's not like the TI calculators where you have to learn their TI basic language. You can actually go on the NumWorks website, create your program in Python, and then download it to your calculator. And now you have any program you want on your calculator that now you could bring to an SAT or an AP test or anything like that. I feel like that just gives kids a huge inspiration. I wrote a program that I'm using on my calculator is just huge. I think so much of what we do in math seems so disconnected from the real world. I mean, and to be able to give them something that's connected to the real world is very inspiring to me. I mean, I'm sorry that I'm talking so much, but I think that this year of having to be hybrid and remote has really shook up what we should be doing in math education, because we've had a lot of times where people are the kids are just solving problems with photomath, So then there's a question well, why are we having them solve problems that they can solve with photomath? Where should we be going with math education? What questions should we be asking? What kind of things should we be teaching? Maybe we shouldn't be teaching how to solve problems just to solve problem. Maybe we should be teaching how to solve problems so you can program a program to solve the problem for you. So I feel like that's the connection I want to go with there.
Yeah, I really like that. I think that makes a lot of sense.
As you were talking, and we're talking about geometry, and we're talking about the coordinate plane stuff. One of the programs I went ahead and opened up again so I could see it is in geometry. I have. See if I got that. There we go. So this is one of the final outputs from one of the geometry programs where the students are only inputting these 3 coordinates. With Pencilcode, I have to do this one at a time, and I can run it so you guys can see it. But I called this solving triangles, and at the end of our trig unit, when we're talking sine, cosine, and tangent, we do all of this. And the students that have already done, doing the distance formula, they've already done, about half of this project, and then we bring the trig into it, and they code law of sines, law of cosines, and they do all this work to show it and graph it and everything else. And look at all that information they get from this program. And think about doing that up by hand and how long that takes students and how frustrated they get because of the time commitment. Where as we look at doing something with code, we can break it down to a point where they're teaching that. That's what I love about doing programming. You literally have to teach a computer how to do this. So you have to understand this on a more fundamental level.
Yes.
Yeah, so when we talk about valid assessment, that's what Lisa, you were getting at, is when they have to create a program like this, we're truly assessing their skills versus something that can just be solved by photo math.
Absolutely.
I keep throwing things in the comments just for people that are watching, so you can check out some links there. But go ahead. I think someone was about to talk.
Oh, I was just going to say, like, photo math, as much as it is a pain in our butts as math teachers, like, it's pretty freaking impressive. Like, that somebody made that program. Like, that's just the usability of that is crazy.
I was talking with one of my students today. I kept hearing the photo click in class, you know, because I have my in-person group in the morning. And I just said, you know, I didn't tell you guys you could take pictures of things in my class. It would be respectful if you would ask me first. And the student fully admitted that they were using photomath to check their work. Now, I'm pretty sure this is a pretty good student. They're trying this stuff out. They know that it's, and I talked to them about the tools and how we used to have the odd numbered answers in the back of the book, but our current textbook that we have for our school doesn't anymore. There is ways to go and find it, but you know, we talked about using tools appropriately. And I warned them, I said, you know, maybe right now in Algebra 1, photomath is, or, you know, helpful, but it's not helpful in geometry. It is not helpful at all in geometry. It's not helpful in Algebra 2.
And it's not helpful for pre-calculus either, just so they know, or physics with the math.
So it's that warning, you know, use the tools strategically, effectively, but not to avoid. You know, and that was a good learning moment in class today.
Absolutely.
So, and we've been kind of talking about this, but our next kind of prompt was, why do we believe that programming increases engagement and interest in math class? Or isn't it actually increase interest in math class? Will students enjoy math class more if everyone was starting to kind of do these kind of projects and ideas we've been talking about?
I do. I think that it makes it, having taught the Algebra 2 for the 21st century, and that class is definitely targeted at students who, at our school, I don't think that's true at Simi, but we were looking for a class that was UC approved, that was an alternate to Algebra 2, that had a career path component, and you know, it was already done for us. It's challenging to teach computational thinking to students who struggle in math, right? That's not an easy thing to do. So there's definitely a challenge there. But I do feel like, again, the connection that they're making between the math that they're doing and what they can see happen in front of them gives them a little fire, I think. And I mean, are we all both math and computer science teachers? I don't know. I will tell you that in your computer science class, kids always feel like this is a fun class. Like, I enjoy this class. Like, I'm solving a problem. They're like excited. And it's not just like the smartest kids who enjoy that. Like, all levels of kids enjoy the process of, I'm given a problem and I'm solving it. And look, it worked. It's like so exciting to them. So to bring that kind of fun into a math class, I think is going to always be helpful. But it is like definitely a challenge to get them to a point where they can write a program on their own, for sure, 100%. And that's why I love Pencilcode so much, and Scratch, because you can sort of get them started on simple things really quickly.
Yeah.
I mean, you can write a program in Pencilcode that does really cool stuff like very fast, you know.
I agree.
That's one of the things.
Has anyone done like Turtle with Python, which is very similar? Dr. Mitchell, with that way?
Yeah, I know my students, we've used Code Sculptor is a #1 that I love to use with my students. And the one thing just in programming, things change, particularly with Python. It started with Python 1. We're at Python 3 now, but they're also in development of Python 4 that's coming out as well. But I love what Lisa said. It does excite the students. It excites them so much in the class. And, you know, with us going over, we're doing projects of animation, and we're also doing a project on emojis. And they did emojis in Python, but in order to do that, they had to do their X and Y coordinates, and they had to get out that old graphing paper, you know, electronically, but still they had to plot those. And it was amazing to them to get all the shapes in there. We use polygons, we use lines. And so it's an amazing thing where it's like, it doesn't seem like it's math anymore, you know, when it excites them like that.
Yeah, that was one of the things that a lot of my students were talking about when they started diving into the code, is that they really did understand that math better. You know, I found, because I had been doing intervention for so long before I started doing this, that a lot of students that really struggled with math would gravitate towards my classes. And so once we got over that initial hurdle that, yes, now you're doing not just math, but you're doing something a little bit more, and we're going to have some fun with it, because there's that little hurdle that you have to get over first about the idea that these projects, these code things, are in addition to the regular work. They start just getting into it, and I make sure that they understand everything I do, and what I want with my design for it is to be a collaborative effort. No student writes one program all by themselves. So we can break these up and have individual parts that you have to do, but then they get to see how the whole thing comes together. And that helps to show them that this is how the real world works when it comes to programming anyway. You're always going to be working with a team. You're never going to be solo, you know, and that helps them, that helps relieve that stress at first. They're not doing this alone.
Yeah.
I think it requires us as teachers too to really like step out of our comfort zone, especially as math teachers, because when you're a math teacher, like math doesn't change. Like when you're a geometry teacher, like I taught geometry for like 12 years. I taught the same lessons the same way, like every year. But when you bring in something like computer science, you have to be prepared for like, I don't even know how this lesson is going to go. I don't even know, like it's a lot, you know, it's work. You have to like put in the time and energy, and you have to just be accepting of the fact that you kind of are giving up a lot of control of what happens in your classroom. Like Jeramie said, he was like, let's figure this out together. And sometimes that's like really, sometimes that like is really inspiring to a kid when you say, I don't know how to do this. Like, can we do this together? And they're so not used to that relationship with a teacher, that I think that is very a positive, really positive experience to have with students.
Creates a really
I definitely agree with that. Oh, sorry. I was just going to say, I totally agree with that, because that just happened. My students, we use EarSketch, which is by Georgia Tech University, Georgia Tech, and they were creating a ringtone, coding it, and I was coding mine too. But I ran into a snare on line 13. And so I sent it out to all my students and I said, hey, can you guys kind of help me? I'm stuck right here. And I think some of the students at first, was like, is she for real? Is Dr. Mitchell having a problem with code? No way. Like, she helps us all the time, right? And she's having a problem. And so finally I had 3 students, and I announced it to the class. I said, thank you to the 3 students that really took my question seriously. And, it did give them like, wow, I helped her to figure out what was wrong with line 13. And it worked in my ringtone, and they loved my, ringtone of coding that I did.
Yeah. Air sketch is something that's also very, very engaging, I would say, for students.
Yeah.
So, we started to talk about like pencil code and Scratch and Python. Just from each of you too, like, what do you think are the best tools to, if we were to tomorrow start to just have every math teacher, starting to do this, what would be? Do we think those are the best tools? What are some of the best? So some of my experience working with math teachers, they do tend to like Python a lot. Like once they actually learn it, they feel like it's very usable, beginner friendly, and it just makes sense to math people. So that's definitely one of mine for the text-based languages. That does, I think, make a lot of sense. But I'd like to hear from you guys. What have you seen work? What do you think works for math teachers that don't have as a lot of programming experience? What's the easy entry level stuff?
Well, you have quite a few. Like I had mentioned, Code Sculptor is definitely a great platform to utilize, but I also use a program through Amazon engineering program that they have, which is with adhesive. I love their inside of what I call the inside platform that they have. And then also I've used like Codester and VidCode, because that's for students that are more visual and like to do video and more graphics. So for me, I think, just starting out would be good. And then also Trinket is another one, because it has the turtle, as well. So I would say those are my top 4, and I'm gonna stop right there because I could go on for days, because y'all know I do this every day, and we definitely like to give the students a variety, so it won't be so it'll be new and fresh for them. So I do try a variety, and I would say one more is Ear Sketch, because students love music, and it is a excellent platform for students that are musically inclined, and it's their first time learning like Python programming.
Not to put you on the spot with that, but have you, just as my curiosity, have you tried to teach any math lessons and used Air Sketch specifically? Just,
no,
just my curiosity. Okay.
I haven't, but it's embedded in. Like I always say with the Python programming, it's embedded in. With Ear Sketch, how math is, comes along is through algebra. And they have to do the loops, when they have to do different loops, and they have to know like the count of the tempo, the pitch, and things of that nature. They have to code, a little bit there, and they got to know how to multiply. You got to get it in there right.
Yeah, no, there are definitely some things you can for sure go over with that. So, Lisa, Jeramie, any thoughts on this?
I don't think I have anything to add besides, the programs you mentioned.
Yeah.
I think I do want to say that I think like when you're going down this road, what's super helpful is a community of other teachers that you can turn to for help. And so I think joining like a Facebook group of, educators using Python or whatever it is, because you're going to have a lot of questions, and if you have to figure it all out yourself, you're going to go insane. So whatever it is, that you find a community that is going to support you through this process. And like I know like I wanted to give Coding Rooms a huge shout out, because Coding Rooms, I was new to Coding Rooms this year. I don't know how long they've been around, but like having used other platforms to have students code in, sometimes like I would just spend hours trying to figure things out, and now in Coding Rooms I just like open the chat and you guys and I'm like, hey, how do I do something? and they're always there. And like, that is just a lifesaver when you're a teacher. So having a community that you can turn to and ask questions is going to be more important, I think, than anything else.
Yeah, as a coding rooms teacher myself, I very much appreciate the support that they give as a business, and that their platform worked really well in my classroom.
I don't know if they have pencil code in coding rooms yet, but
no,
maybe.
I looked.
Not yet, but they have everything else though.
They have,
But they have-
And I'm glad you said that. They have everything else, but
They have Python with Turtle, which
Yeah.
So if
Yeah.
you do any
Python with
graphic
Turtle.
stuff, I do all kinds of crazy graphics projects. So it works. This is just
Mhm.
desktop. Oh, what was it you guys mentioned? I didn't even hear. They don't have.
The pencil code kind of
Oh,
thing.
system.
Pencil code is it defaults to a modified version of CoffeeScript, of JavaScript, which is
Yeah.
CoffeeScript, right?
JavaScript.
Yep.
That's
And
right.
so what I liked about it and why I've been kind of just there, because for the last 5 years, like I said, I've been creating all of this pretty much on my own. When I do get stuck, I do reach out to other people that are using pencil code. I'll reach out to Dan a little bit. I've actually reached out to the creator of pencil code himself, and he's gotten back to me a few times on a few things that I've just got stuck. And so I gotta give him a shout out. His name is, of course, now I'm gonna blank on the last name.
You should have written all these names down, Jeramie.
I
Yeah, you have to
should
write them
have.
down.
I should have.
Have your little speech with all the names of all the people you're supposed to thank. Joe, do you?
I'll get-
do you
I'll get back to that in a minute.
Joe,
I'll get back to the name in a minute.
Do you use any? Do you teach any math classes, Joe?
I do not. So,
Oh.
so unique here to spark the conversation. I've worked with math teachers. My school is looking to create a much deeper connection with the career and tech programs, which I teach in the career and tech programs, and with the other academic courses. So we have been talking about math for some of the more STEM programs for the math classes to use programming. We're starting these conversations. So that's kind of where I'm interested in this. But I don't teach any math classes. So the three of you are more dual math and computer science teacher. I'm just, I hang out with the math teachers. That's just about it.
Oh, the other thing that I wanted to mention, and it's not really a computer programming language, but I think it's a good step into the world of programming, is something like Excel or Google Sheets, where you're putting in formulas based on cells. And using that in any kind of math course to create like a calculator where you would type in a cell and another cell stuff would appear. I think that's a really good, like, get your feet wet kind of project to do in a math class, because it is kind of using this idea of programming a little bit. I mean, you're writing formulas that relate to cells. And I think that's for me, 10, 15 years ago, having students use Excel to do things was exciting. And personally, I have a daughter who's in her late 20s, and, she grew up with a math teacher mom. And so she's always making fun of me afterwards, like, really using all that math I learned in high school all the time. But she'll say, what she uses every day is Excel. She's like a huge, that's like in the real world, that's a tool that's really being used. Why are we like not teaching Excel integrated into our math classes? Like, I don't know.
You're absolutely right.
Yeah.
So about 5 years ago, there was a lot of conversation around that. Because even so, I'm part of a pre-engineering program. I teach just all the computer programming and CS stuff. And they were talking about that. We were talking to the university, and they were saying, our first course really has a lot of stuff to do with Excel, to analyze all this, and engineering, statistics, and all this other stuff. And we said, why aren't we using this in math class more, or doing a lot of things with that? And it is really, really important, because how many people, I would say, if we were to look at a career cluster business is probably one of the largest ones, right? Where just people work in business, whatever it may be, financial, all different areas. Sales, they all use Excel for their spreadsheets. And the more proficient they are, especially with doing formulas and even just data visualizations, graphs and stuff like that, it would benefit them greatly.
I think like one of the problems we have in math education is we have so many standards we have to get through in a given year. And we always feel like we have to teach all the standards. And that's because our field of study is state tested. You know, like you have English and math are state tested, you know, across the country. So you always feel this pressure as a math teacher, like I have to cover these standards. Where am I going to bring in something else? And I think what we have to do is, as math teachers, it's like free ourselves a little bit from the standards and say, like, we could give up something and focus on, for example, like, you know, we could focus on matrices and spend like a lot of time looking at using and programming matrices and things like that. And that, you know, I think that's the challenge of a math teacher is what can I let go of to make my curriculum useful and helpful and deeper, you know, instead of like a standard every day, maybe we could like really build on something. And I think that's what like we tried to do in the Algebra 2 for the 21st century is we really did say, we can't teach everything and teach programming to these kids. It's like not even possible. We really just like narrowed down to like three or four major topics and tried to find like a string through them. Like really what we were looking for was like, can we do this idea of like data analysis through all of, so like looking at linear graphs, looking at quadratic graphs, looking at polynomial graphs, looking at exponential graphs, looking at trigonometric graphs. So we really just kind of focused on that and really focused on like the graphing and the data analysis and regression, and that was kind of our guiding light there. And that's, I think, what we have to do as math teachers.
Absolutely.
So based on where you just went, go ahead, Jeramie. I'll let you finish first. I'll let you.
I was just going to say one of the first things that I did when I started bringing the coding into the classroom was look for what is it that I can remove in order to replace with the coding. See, the idea is that when you bring these project-based, when you bring these computer programs into your classroom, it's to enhance the class. It's not, by doing that, you have to look at what is it that you're doing that you don't necessarily need. And if there's a way that you can figure something out. One of the things that I did get rid of is some of my interim assessments. I was one of those teachers that originally was doing that quiz every Friday, you know, and now every Friday becomes that, what are we doing on code? So let's do this little code project on Friday so I could still do the math, but also bring the code in. And so sometimes it becomes Thursday and Friday for code, Monday, Tuesday, Wednesday, straight math. So you start figuring out where that balance is. And you still assess, but your assessments become different. Writing code becomes that assessment that I got rid of. And that's a huge thing. When you start thinking about this, everybody says, okay, this is more, this is more, this is more. Well, you can't have more unless you also get a little less.
So where I was going next was in education. A lot of people are talking about the one benefit that will, or the one positive that will come out of this pandemic, and us having to deal with school in the way we have for over a year now, is that most likely our educational systems and our curriculums could be more efficient because we've started to work with less time. So now we can be a little bit more efficient, and possibly we could start to do more programming in math classes when we have a better idea of how to not stretch out the time, but instead have less time to cover certain material. So with that in mind, I'd love to hear what you guys think about that, as well as our last prompt was, how can computer science and programming address the achievement gap And with this learning loss from the pandemic too, how could programming kind of help us with that?
It's a lot on my mind with it. Yeah, well, I'm gonna be brave. I'm gonna be brave because actually that's what I actually saw, because I had started out as a geometry teacher / enrichment, and with my students with enrichment, I had all math levels, and I decided to link up with code.org. And with their platform, I was able to see those different projects. Again, I really believe in a project base where students can get as many skills that you're trying to with the content. And so I was able to, infuse that. And even now, I'm always bringing up, and if you talk to your math teacher, they could tell you a little bit more of how this parallel. So I know some of my math colleagues, they just love, they're like, yes, Dr. Mitchell reeled it in on this Python class. And I think with the achievement gap, it just giving them, as I say, another way to look at the glass full. A student may struggle with, system of equations, but if we get them to look at another type of assessment, if we would, to give them another opportunity to show what skills they can show and share and master with a different type. And I have to echo, this is what the pandemic has given us to think. We have to think outside of the box now, because the way that we used to do it on the pen and paper, now we have to do some things that are a little bit digital and maybe even hands off per se.
One of the things I've mentioned already, and I like to say it again, the level of understanding that you have to do programming really makes it so that you are, as we all know, you learn better when you teach something to somebody else. And what a better student than the computer? The computer does not know what to do before you start telling it what to do. And so by making the student become that teacher, they have to really know. And that's an amazing accomplishment for a lot of these students that are struggling with math. We talk before they even get into the code. How do we break this down? What does it look like? I mean, think about this for a second for programming. How do you store a fraction? So in my Algebra 1 class, right at the beginning, I teach them to store a fraction as a list, as a numerator and a denominator. Yep. One object, two numbers. And it focuses them. You know how many students don't like fractions? And then you sit there and talk to them about how it's one object, two numbers. And then when you're doing the code with that, you're interacting with both numbers. They start to realize, oh, this isn't so bad.
Yeah, I like that a lot.
Yeah. And also with word problems, I was just thinking what you were saying too. This really helps them to problem solve and critically think and put those plans together that we've been trying to tell them before, with the word problems, strategies. Now it's right in the open where they have to visually and get that plan together to program as well.
All right, so for our last kind of discussion point is, what can we do to encourage other math educators to start to combine programming in their normal math instruction? Certainly, we all believe here that it will increase engagement. So how can we get others to do it? I think first step really is, so I'll kind of lead off, creating resources to help them. So Jeramie, some of the work you're doing and stuff, having those resources, those ready-made lessons could really help them out. But what else? What are some other things?
I think it starts actually with your site admin. So you have to have admin that are willing to support a teacher giving something a try. Because that's the first and foremost that everybody's going to talk about. We talked about it earlier. We all know that technology doesn't necessarily work 100% the first time you do it. And so having someone that's willing to support you, whether you are super successful or you struggle a little bit, and give it the time it needs. You know, if you're not going to be given at least 2 years to try this out, then you're not going to be very successful with it. You're going to say, hey, you know what? It didn't work. I'm done. You want to give it at least 2 years. You got to try it out. You got to get in there and basically you got to get your hands dirty. I mean, this is when you write code, sometimes it works, sometimes it doesn't. And then being able to be that person, and as a teacher in the classroom, being able to say, you know what, I didn't get this to work. You know, 2 of us have shared that already. And that's an amazing, authentic learning experience for kids. When they can teach the teacher something, they love that.
Yeah. Lisa, Dr. Mitchell, anything on that note?
I don't know. I think, you know, it grows. You know, if you think about like the work that Jeramie and Dan did at Simi Valley High School, and they gave a workshop that I attended, you know, and then now I'm doing it at my school and spreads from my school. And then I think, you know, you just got to keep trying to show people that it works. I think that like the thing when I went to Jeramie's workshop, one of the things that was so meaningful to me was when you did bring in the students and they talked about their experience in your class. And it was real, like, it's one thing for us to be like, I do this great thing in my class, like I'm, you know, but it's a different thing to like hear from the kids, like how much it had an effect on them that they, and I think it was like, we were there like on a Saturday, if I remember. I think it was I can't remember. But
it was a Friday and a Saturday.
Yeah, and I think the kids like came into school on Saturday to come and talk to us, and they were like so excited to talk to us. And I think that was just like really inspiring. So I think like letting the kids sell it is huge too. I don't know how we do that, but you know, I just always think about like, I'm a huge Desmos person, and I love like in the Desmos group when people share like, look at this cool art my kids did in Desmos. And some of you are like, your kids do that? I want my kids to do that, you know, kind of thing. Like, so sharing things that kids did, I think is pretty inspiring. I don't know.
Yeah.
I don't know.
Yeah, I would have to echo and say that that is definitely where it's at too, because like you said, we can be like, yes, I taught an amazing lesson on this, but you know, your audience, which is our students, that's the really the key and the loop of it all, you know, to link it all together. And I definitely would agree with the resources, because I know when I took my first leap in taking training, you know, over 200 hours, I was in deep. I wanted to make sure that I knew how to facilitate with my students, and other teachers were there, you know, at this professional development, and they could see, oh, there's more teachers that are not, you know, great. You know, I am a CTE teacher, but, you know, here are math and science teachers that really want to share, you know, in the programming aspect and infusing that into, you know, mathematics.
I do want to give a huge shout out to Desmos and opening up their, you know, computational layer. Like, I think that has actually brought in a lot of math teachers to like learn computer science. Like, they're like, I don't know any computer science, but I want to learn this computational layer so I can make these Desmos activities. And like suddenly they're learning computer science because they're learning like if statements and or statements and connecting things. And like, you know, I think that's really cool. That's a thing that's happening. And then I've heard of like teachers who use a lot of Desmos having their kids, their students make Desmos activities by teaching their students the computational layer. I'm like, that, I mean, there it is. There's a huge connection right there. And the kids are like so excited about like, well, I can make an activity. And like, that's really cool. And like, I love that about the world of computer science, just this like open source kind of like, here it is, like, and you know, that's so cool.
Yeah, it is really great. There's so many free resources, free curriculum, free lessons. It is amazing. It's one of the things I value most about the computer science kind of community, that they truly embrace the open source you know, mentality, and it's amazing. One of the things I'll throw a plug in, it was as we were talking, I thought about it, is right here where I'm from in Rhode Island, we have Ivy League Brown University, and they support a curriculum called Bootstrap. So I'm going to throw it in the comments there, and they have an algebra course, data science course, physics course. They have some coursework around this. So if you're looking for more resources on courses that can align to some of the standards you're trying to cover, Bootstrap is definitely one to check out also.
I do think, like, I went to a workshop a few years ago. UC Davis has this whole like trying to integrate STEM and math, and they have like this whole curriculum, but it costs money. But they have like these little robots and all this stuff, like, and it's really big up there around Davis. And they have like the curriculum's all done for you, it's all laid out, and we couldn't afford it at the time, but I thought that was really cool.
And I think we focus definitely a lot on high school and the upper grade levels, but certainly at the younger grade levels. And I've seen some curriculum out there, don't know them off the top of my head because I focus on high school a lot and working with high school teachers. But with robotics and with some other things to teach these elementary grade students math and really make it engaging. And I think there's an amazing opportunity there. And in a lot of the research that I've read, that you know, around that 4th, 5th, 6th grade is where you start to lose some kids that think they're not good at math. And how amazing if they were having these engaging activities, if we didn't lose them, they would continue to have confidence that they could do it.
Oh, wow.
There's a lot there around things like Lego robotics, where you still got the kids that like building with Legos, because that's that age group where they start to lose that interest. But you start getting the mechanics into Legos, and then they start getting back into it. So the kids do that. I went to a few workshops on that years ago, and I taught in Gilroy for a while, so I was up there in the Central California area, and there was a big push for more of that hands-on math learning in robotics, and that, again, that still ties in that computer science and math, and you talk about all the things you have to do with that. So yeah, definitely that's another avenue to pursue. What I have seen and what I've been looking at is a lot of people using things like Scratch with elementary school kids, so they get a chance to see the puzzle pieces coming together. Very visual, very nice to see. So that's definitely a good place to go and start thinking about what you could do, and just thinking about the math that you're actually doing. You know, keeping it as simple as you can.
I was thinking that it's funny you said Scratch. I was going to say that a lot of the elementary schools kind of do some things with Scratch with students, but what a great opportunity to do it incorporate your math lessons into that time where they're using Scratch. Even just multiplication, division, even addition and subtraction. There's really cool, engaging things you can do with moving the characters around, or all kinds of things that students would enjoy. We do have a comment over here from Tina that I thought was really cool that we can kind of close with, unless somebody else. So if you're watching live, please put any comments over on the actual live stream, so we can answer some questions and talk about some things. But Tina said, how do you think this ties with the conceptual understanding of mathematics beyond just the memorization of the procedures to kind of solve the things? So we see that a lot, right? Especially in high school, that students will just kind of try to memorize what they need to do for that particular test, so then they can just kind of go through those things. But once the next unit comes, they really don't know how to do those, whatever it may be that we're doing. What are your thoughts on that? Does programming really help with this more deeper understanding of math?
I don't know if it helps with a deeper understanding of math, but I think what it does do is give you a problem solving kind of experience, I think isn't that what we're trying to do in math, is teach them to be critical thinker problem solvers. And that really is what you're doing when you're writing a program, is you're solving a problem. And so I don't know if I don't even know if I'm answering the question, but I don't know if it's going to give you a conceptual idea of the math, but it's definitely going to make you a better problem solver. And I think about Jeramie's curriculum, where it builds all year long, right? You have to know how to solve this program, write this program in order to write the next program, and everything kind of builds on each other. And then you're not forgetting what you learned, back at the beginning, because you need it now to do this program, right? Remember when we did whatever, we're going to need it in this program.
So that's what I was going to say, is I've tried to build the program so they do what I like to, in my class I call it recycling code. Once I teach the students about the distance formula, anytime we want to know the distance between 2 points, and we have that in code somewhere again, just to think about in geometry, one of the first units we do is midpoint and distance. But after that, if I'm doing rigid motion and I want to prove it, I'm going to use side, side, side for the triangles, and we're using that distance formula again that we already did, so we talk about it again. I have a program that my students write that at the end writes its own coordinate geometry proof. It actually writes its own proof. And when they do that, again, we got to go back and look at it. We're doing quadrilateral proofs, and everything there is about slopes and distances. So we're looking at, again, we're revising it. So the repetition breeds familiarity. And that's one of the things I like to talk with my students about. The main reason why I'm so good at math isn't because I'm any better at it than them. I'm just way more familiar with it than they are. And so by doing the stuff that we're doing with the code, we get that familiarity.
Yeah. I often say that with my students with computer programming, as well as sometimes there's issues. I can spot it right away. I walk up to their computer, that's what's wrong, and they go, "How do you do that so fast?" They almost get upset with me that I can find it so fast. So it's just years of more experience. That's all it is.
Exactly.
Especially, I would say finding these quirky bugs in things is just because of so many students, same thing over and over. Again, now I kind of know what to look for, and that's all it is experience. Emmanuel said something really interesting here in the chat. So the semantics of the language are critically important. Make sure that the language is supporting math and not undermining it. So that's really interesting. I think making sure that the semantics are getting in the way also is something that I think is important, which is the reason why some of these block-based programming environments may be really the way to go in a math class, I would say, is because we don't want students to stumble on, or trip on those things. We do care about them thinking about the math and being able to very easily create something cool with the math. I would say is important there. And Emmanuel goes on to say that coding has historically failed to boost math outcomes because of some of these things. But go ahead.
I think that's what's kind of cool about something like Python is the syntax of Python is sort of intuitive in a way compared to Java or JavaScript that print something, we're just going to type print. We don't have to think about that. But you're right, block-based.
This is true. Emmanuel says the semantics doesn't necessarily not the same as syntax, so the blocks don't really change that. Completely understandable. But And that was my bad, really bringing up the syntax. So that's what Python can help with, and blocks help with, is they're not syntax heavy. Blocks don't have syntax.
Pencilcode does help with that as well, because it's all spaces and tab delineated. There's no syntax. It's all about this form and structure. So it takes what is good about the block-based language and then allows you to switch it over to a typed-based language. So the kids get the idea of learning the type-based language and the structure of that, but they don't have to worry about the semicolons and curly brackets. So that's where I use that language, because when I'm using, putting this stuff into the math classes, they're not going to get tripped up over the syntax.
Very good. All right, anything else as we close up this conversation?
Just want to give my official shout out. I want to give my official shout out to David Bao, the creator of Pencilcode. I got his name finally. Sorry, I just did not remember it at the time.
Yeah, you're gonna have to write that down so you got it next time.
I totally blanked on his last name. I knew his first name was David, but I couldn't remember his last name. I got like 4 or 5 Davids in class right now, and I just could not put it there.
All right, well, thank each of you so much for a really engaging, thought-provoking chat. We appreciate it. Thanks everyone for watching, anybody who watches this later. Goodbye and have a wonderful night.